Hello, this is Dawson Saunders, and this is the rotational molding assignment for ETM 2080 Industrial Plastics. Okay, so to begin, we have part number one, the product name. This is the rubber duck. The material used is 2 ounces of low density polyethylene and 4 scoops of yellow pigment. The mold for this part was made out of aluminum. It was in fair condition. It had some grime and burn residue left over. The machines and equipment used, the mold, the backing plate, the oven, and the gloves. Processing time, just from watching the videos, I tried to add it all up. It was approximately 32 minutes. That being split up into 5 minutes of prep, 20 minutes in the oven cycle, and 6 to 7 minutes of finishing operations. So the method of measurement, the 2 ounces were measured using the cup with the lines on the side in the video, and the pigment was scooped out using one end of a popsicle stick. Part defects for this particular part. This part had, after it came out of the mold, it had a very porous surface, and you can kind of see in the picture the nose didn't really form properly. So okay, so now on to part two, which is the pumpkin. The material used for the pumpkin was 108 grams of high density polyethylene and 3 scoops of orange pigment. This mold is cast aluminum as well, similar to the duck. And it was kind of in the same condition as the duck was. It was fair. There's a few wrinkles in the mold itself, and then a couple defects towards the bottom. So machines and equipment used, same as the last part. Used the mold, the backing plate, the oven, the sink, and gloves. Processing time was 10 minutes more than the last part, and that's due to it being high density polyethylene, which has a longer oven cycle, but the rest is the same. You have the same 5 minutes of prep, but you have 30 instead of 20 minutes in the oven, and 6 to 7 minutes of finishing operations. The method of measurement was 108 grams. It wasn't really specified in the video. I assume it was similar to the last way, using one of those measuring cups, and pigment was scooped out with a popsicle stick yet again. Part defects, it's clearly visible in the picture. It didn't form. That could be from it not reaching temp, not rotating correctly, just something like that, but it didn't form at all. So, well, not necessarily at all. It didn't take full shape. You can kind of see where it molded in a little bit. Moving on to part number three, we have the Christmas tree. The material used, it didn't give an exact amount in the video, but it was half a mold of high density polyethylene, and similar to material, it didn't really give an amount of pigment, but there obviously was some used. Mold material is the same, aluminum or cast aluminum. This was actually the best condition mold out of all 3 parts. There wasn't really any imperfections. Same as the last 2 parts, same machines and equipment. You have the mold, the backing plate, the oven, the sink, and the gloves. Just like the other high density polyethylene part, it's 42 minutes due to the added 10 minutes of oven cycle. So 5 minutes of prep, 30 minutes in the oven, 6 to 7 minutes of finishing operations. For this part, it was predetermined in the video, the amounts that were used of HDP and pigment. So there really wasn't any method of measurement. But part defects, only half really fully formed. You can see we're looking at what I would call the top. The bottom, the piece that's still in the mold, um, it's pretty consistently thick. It has the whole shape, and then you have this side, which obviously has holes and just doesn't look very good. Okay, so now on to part number 4, which is the final part, and the part I believe to have formed the best is the 4-leaf clover. Uh, the material used is low density polyethylene and 1.5 scoops of pigment. Similar to the previous 3, mold material is aluminum or cast aluminum. This mold is in fairly good condition. You can see I actually got some of the mold in the picture, so you can see the burnt residue on it, which is that black stuff all around. Machines and equipment, same exact as the last 3: mold, backing plate, oven, sink, and gloves. Unlike the last 2 parts, this part goes back to low density polyethylene, so you're back at that approximately 32-minute total of processing time, with 5 minutes of prep, 20 minutes in the oven, and 6 to 7 minutes in finishing operations. Just like the last part, predetermined amounts were used of material and, well, not pigment. It was 1.5 scoops of pigment, but predetermined amounts of the low density polyethylene were used. Like I said, I think this part formed the best, but you can still see some of the small holes. This picture isn't very good resolution, but you can see about some small holes, and then the pigment didn't really fully mix. It's not as vibrantly green as it's supposed to be. So, okay, so now that we've seen all the parts, after watching the videos, I came up with the 3 most important things to ensure you get a good part every time you do this process. The first thing is properly determining the amount of material and pigment to put into the mold. Number 2 is setting oven to a proper temperature and checking that the mechanism is freely rotating and heating for the entire designated time cycle. And last but not least, uniform cooling of the item and delicate removal of the part from the mold is also very, very important. Last but not least, this is my take on how to improve the rotomolding process as shown in the video. I guess the only test I could think to run would be a strict temperature test, just to minimize variation in the temperature during the oven cycle. I remember from the video when the setting on the oven itself and the actual thermometer were reading different. So just getting that oven calibrated is a big step. Procedures to implement: more accurate methods of measurement, a proper mixing device, and a better cooling station. By more accurate methods of measurement, I didn't really see much measurement in the video, but just using those cups, maybe, I mean, this is not really logical to think about in a lab perspective like we have here, but maybe in a lean manufacturing, so maybe a bigger company, we have machines that accurately dispense the right amount of material and pigment. Going into the next one with the mixing device, that took a good bit of time during prep. Having something, I mean, it could be something similar to a kitchen mixing device that you can use, but just something to mix it up faster because that took a good bit of time. Last but not least is a better cooling station. While the sink works, it's just not really effective for even and uniform cooling. What I saw wrong, while the oven cycle is inevitable, you're gonna have that 20 or 30 minutes, no matter what you do. We need to reduce the time in prep and finishing steps while maintaining part quality. So, how to move forward with that? Um, I said a redesign of the backing plates. They just look. They took a good bit of time to set up with the metal ribbon and the wing nuts. Uh, Maybe just something with that clamps the mold down or holds it better. I guess I was just thinking there's got to be a better way to do that. Um, Number two, I would introduce a machine to measure and mix material, similar to what I said in processes to implement. Um, Number three, redesign of the molds. Uh, while uh, I'm sure these molds in the videos have had fair use or a good bit of use. Um, a thing I found with them is it took a good bit of time to tighten them shut, and it was also a pain to uh, get them open to get the part out. So maybe uh, a cast aluminum mold with some sort of clamp that will work just as good as the bolt and wing nut, but also make it easier to split the mold apart in the end. And then number four, improvements to the cooling station. While I understand this is a lab for school and not a large manufacturing company for rotomotive parts, just uh, even cooling is very important, or uniform cooling, that is. Just as far as like shrinking and stuff like that goes, you want to get it nice and cool down to room temperature. And I mean, while the sink works, it could be better. And that is all for this presentation.